batteries are a relatively new asset class, and the technology is changing so fast. And of course, because we work with so many different players, we can also tell them, hey, we've seen this play out 20 times with companies just like you, and in 18 out of 20 cases, this was the better decision, so we recommend you go that way.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about making the most out of the data batteries provide. Energy storage is critical if we want more renewable energy on the grid, and lithium-ion batteries, responsible now for most of the new storage capacity, need to stay healthy. My guess is these batteries can be sensitive to temperature, charge-discharge cycles, and changes in voltage. The good news is each of these lithium-ion cells contains a chip that broadcasts this information. The bad news is that most battery management systems, or BMS, ignore it. That's not great because these cells could tell the owners if there's a problem. It's no secret several sites have experienced thermal runaway events, which can be catastrophic. At a previous company, I worked on battery augmentations at these sites where lithium-ion modules had degraded to the point that they needed to add more modules to meet the contractual demands of the site. My guest explains that batteries are grouped in series to get the proper voltage. The chips are in the cells, but the cells are grouped into modules. The modules are stacked into racks, and racks make up the battery energy storage system, or BESS. The BMS, he explains, sometimes only monitors data at the rack level. If there's a problem with the individual cell, it's buried within two hierarchies of data. He says the key lies in cloud computing. Take the monitoring off-site, piggyback on the data already provided, and pinpoint the bad cells hidden within these racks of storage. It's their hope that the cloud can provide the confidence to maintain a healthy and productive energy storage system. My guest today is Kai Philip Carries, co-founder and CEO of ACCURE Battery Intelligence, a cloud computing company based in Aachen, Germany. KP founded the company in 2020. He says his experience on several early BESS projects led him to a solution that can analyze a lot of the data that these developers took for granted, which can lead to a lot of headaches later. This was fascinating for me because I saw the results of these challenges firsthand. My focus in this interview was initially safety and reliability, but KP says their tools can also help clients with business decisions and use cases. In fact, we talk about how ACCURE's experience across the gamut of lithium-ion products is perhaps most valuable before anything is designed. And we also talk about the evolving use cases these batteries are tasked with performing. Lithium-ion batteries have a finite number of cycles in their lives. Does it make sense to switch to a business case that spins more cycles than expected if the short-term revenue is greater? I hope you enjoyed my conversation with KP Carries. With Dr. Kai Philip Carries, CEO of ACCURE Battery Intelligence, and he goes by KP. And KP, I spent a little time on BESS projects about 2 years ago where we were planning battery augmentations on systems where the capacity had dropped and we need to add more modules. It seemed kind of like it happened early. It was only after about 3 or 4 years. Was this normal, or could those batteries have theoretically lasted longer?
Oh, that's a very broad question, but just from experience, at ACCURE, we work with well over 30 different big battery sites, and we see a pretty big spread in the quality of the batteries, but also in the load profiles that the companies are putting on these assets. And, you know, the markets are really dynamic, and so sometimes the profiles that they planned within the beginning did not end up being the profiles that they actually put on the batteries, and so degradation rates can be pretty broad. And then, of course, you know, augmentation is not just a question of, oh, we are missing something and we want to go back to normal, but it could also be an opportunity if you get new financing opportunities to just augment or increase the system size because you can make more money with it.
Yeah. Before we get to your system, let's start from the beginning with folks. Let's start with a BMS, battery management system. What is that, and how would they maybe fall short of what you're providing?
Yeah, sure. The BMS is a great thing. And when you look at all different energy technologies, the battery is pretty unique in a way see that every single battery cell, at least for lithium-ion, comes with a small chip that constantly monitors and oversees voltage, current, and temperature. In a gas turbine or in a wind turbine, it's not standard that every part of the overall system has its own data generation. But with batteries, that's the case. And so the role of the BMS, the battery management system, is to make sure that the battery is operating within its specification. Don't overcharge it, don't undercharge it, don't use it outside of its temperature specs. And it also does some rudimentary state estimation. How is the state of charge? How is the state of health? And rudimentary, not meaning this in a disparaging way, but it's a very simple chip. So we shouldn't expect anything from a very cheap, low-cost chip that it can't really do. And so there are some limitations to the more advanced functions that these chips have.
Right. And one of the things I was told, and I think we're seeing a little bit more of this, but a lot of times the BMS is not recording data at, say, the pack level, right? Or the cell level. It might monitor at the module level. A lot of times it's monitoring at the rack level, multiple modules, a whole stack up and down like that. And so that's where I think that level of detail, if you're doing it at the rack, you're getting a very high level view. The more down to the cell level you get, the more potential you have for spotting, the bad eggs, because they will cause the problems, right?
Yeah. Batteries are pretty similar to solar in the way that you have small units that are connected in series to get to a certain voltage. And the voltage typically is in the range of 1000 volts, give or take. And so, with a single battery having 3.6 volts, you need a lot of batteries in series. But that also means that the weakest cell in that serial connection will limit your overall performance. So one bad apple can really impact an entire site. And now the BMS is actually available on cell level always, because this chip is literally connected to the individual cells. However, some of these SCADA systems, like the communication bus that runs through a site, it not always ingests all of the details. So it's typically a design decision. And we have customers that have information down to the cell level available on the SCADA, but also customers that only have rack level data, as you mentioned. And of course, the granularity of the analysis that you can do with these two types of data sets is quite different. But interestingly, actually already with the relatively rough data, you can pinpoint to a surprising level of detail what's going on. And so oftentimes when we start working with customers and they say, oh, our data isn't great, and then we can show them what we can do with it, they get really incentivized in the next sites to have slightly more data, because now that they know what they can do with it, they want it. And the incremental costs are almost zero. It's just a design decision to have a few more bytes going up and down. You don't need bigger cables or whatever. It's set across, when buying, I want the full data. Yes or no?
Yeah. It's amazing how much people, when they see data, they want it. So let's get into ACCURE system. How do you fit into all that?
Yeah, so maybe just 2 sentences about my background. I'm an electrical engineer and I started my career in batteries 15 years ago. And I ended up leading what I believe was at the time the largest research group on stationary batteries in the world for a few years. Back in 2013, we were building a 6 megawatt hour system. At the time, that was huge. And one thing that bothered me for years and years is that all the companies we worked with that were building massive assets, they were putting all this equipment on the field and they were producing terabytes of data through the BMS, which just comes with the site. And then they just didn't care about the data. No one was using it. And there was so much value in it, obviously. And so I thought, after watching this for a few years from the sidelines, we got to do something about it. There is definitely the need for a specialized data service company that brings all the detailed knowledge about battery models and data and machine learning, and just basically serves as a plug-in solution. You funnel your data into our system and we come back with insights about safety, about performance, about lifetime. So that was the hypothesis that we started this company on. And now we're over 70 people and have customers on 6 continents. And we're way above the gigawatt hour mark in Texas alone. So I think things have moved quite nicely. And that's really where we feel comfortable making more out of battery data. I have so many PhDs on my team that just love to nerd out on these things. We have several patents on the topic. And that's basically where we found our sweet spot.
That's great. Congratulations on all that. Let's talk a little bit about the system. So you say it's cloud-based, and what you were describing earlier is, look, the data is in the modules. If you're cloud-based, I'm assuming the SCADA system's already designed, it's already got that pipeline. How are you getting that data at the cell level out back to yourself so you can analyze it and provide feedback for the customers?
So that runs parallel to all the other data flows we have in the site. All the sites are online just to get information about when to charge and discharge. To serve the energy markets, they need to be constantly exchanging information. And so we're basically piggybacking on these existing data streams. And I want to say 9 out of 10, maybe more, of big system integrators already have monitoring systems in place that they offer together with the hardware to the owners and operators. So if you're coming to us with a Fluence system, we already know who to talk to at Fluence, right? Because we have several sites from them, and the same goes for most of the other major tier 1 and tier 2 suppliers. So we have established APIs, in all the different flavors of data transfer. And because the data is already in the cloud, we don't need to retrofit any sensors. We don't need to retrofit any loggers. That makes it really scalable and easy and fast to implement. And once we're done with crunching the numbers, we typically do that once per day, sometimes more often. We feed the information back through a dashboard that has automated warning. So if something's off, we wouldn't wait until you click into the dashboard. You would get an email or a text message, a Slack message, and then we typically have customer check-ins maybe every 2 weeks with our experts just to see how things have developed, if they acted on the recommendations we gave them, and if things were actually better now, stuff like that.
Yeah. KP, what kind of decisions can be made with the information you're giving them?
Yeah, you're based in Texas, right? Texas has an island grid with a lot of wind now and with dynamic market prices. And so storage is an incredibly valuable asset in the Texas power grid right now. But an interesting fact is, on the best day of the year, you could easily make up to 10% of your annual revenue. If ERCOT hits the market cap, you can basically print money with a battery. Now, on the flip side, if your battery is not ready to go on that best day of the year, you can lose 10% of your revenue. And that's really bad, not just for the company, but also for the people responsible for asset management. So what we do on the performance side, for example, is give a clear prediction whether the site will be able to perform to 100% of its specification today or tomorrow or in the next days. From a practical perspective, I can tell you 100% basically never happens on 0 days for 0 customers. It's always a flavor of, is it in the high 90s or is it in the low 90s or worse? And for most business cases, whether it's 93 or 95%, that's an interesting difference. It can be $100,000 a year, but it's not a catastrophe. But if we look at these few days where 5% availability can cost you $500,000 in revenue that day, they want to make sure to hit the highest number that they can get. And so we're really looking into the details of every single cell, of every single rack, of how the racks are balanced against each other. Is there, one rack that's limiting the other ones? These are details that you can't get out of the standard monitoring that comes with the sites, but our algorithms can look one level below the obvious and tell you this battery thinks it's at 80%, but if you start discharging after 70%, it will shut down. We already know that. Don't run into it. And these are recommendations we can give on a daily level.
Yeah, it's not just battery health. And I think that's kind of what we set up, where I usually come from, is from how we're going to make sure that the batteries stay healthy. But your big business proposition is making sure that you understand the markets are able to respond in kind. I've got a panel coming up where I'm going to have 3 ISO managers in the United States. One of the things we're talking about is you got these battery companies and they're participating in the ancillary services market. And then the expectation is you want to maximize battery usage. You also want them to compete in the capacity market. And I think there's a lot of questions right now about, do they have the right state of charge? Are they available? These big grid planners, as more and more batteries get on the field, they want to make sure that it's available. You're also helping with some of that, right? You're helping thread that needle.
Yeah, absolutely. Batteries are a relatively new asset class, and the technology is changing so so fast. 2 years ago, a lot of people thought NMC batteries will be the dominant technology. I would say that anyone with common sense would know 2 years ago that LFP would be the major technology. And now LFP, at least for stationary, really is the dominant technology. But that also means that a lot of the best practices that were developed over the past 5 years don't apply to the new batteries that come out now. So you've got a new technology and people were able to get their hands around best practices and boom, you're back at zero. And now you have a maybe complex portfolio where some of your batteries are still that old technology, some are the new. How do you transfer knowledge? It's a really, I want to say, interesting, but also challenging technology. And what we're really bringing to the table is information. We're really bringing the data that helps people make decisions. And of course, because we work with so many different players, we can also tell them, hey, we've seen this play out 20 times with companies just like you. And in 18 out of 20 cases, this was the better decision. So we recommend you go that way. And that's like the daily operations. Of course, there's also strategic dialogue around, oh, should I increase my merchant share of the battery, which would add more cycles? And then maybe it doesn't last for 12 years, only for 11 or 10. But honestly, a lot of companies right now, they're so focused on short-term revenue that discussions around aging, optimization are relatively theoretical, I would say. So most of our customers, if they have to prioritize, it's always short-term revenue right now.
Yeah, I understand that. It kind of makes me wonder, how early are you having conversations with some of these developers? If you're able to give that kind of data and guide what they choose to participate in from a market standpoint, how early are those conversations happening? It almost seems like it'd be happening as they're trying to put together the business proposition for the project.
Yeah, one of the unique benefits that we have as a highly specialized company is we see the majority of the market, and we have pretty unique insights into the quality of some suppliers and the warranty conditions that company gets versus company B gets, and some of the procurement details, factory acceptance tests. Oftentimes companies bring us into the process relatively early saying, hey, ACCURE, can you just sanity check this? We got this warranty condition. It seems okay, but have you seen better ones? What are the points where we could negotiate a bit? We're really happy to help in this early stage, because if we can support a customer with good warranty conditions and good technical specifications, making claims is much easier later on. Because obviously when something goes wrong, we also support our customer with claim management, and it's much easier to just go to the supplier and say, look, we have a very clear spec. You're missing that. How can we fix it? Versus having something that's kind of vague and could be interpreted this way or another. We really like to be involved before a system goes live so that we can set everything up in the right way to reduce ambiguity in the long term.
Yeah. Going back to the battery health thing, back to the original promise, you could tell if a cell is bad in an entire rack of batteries, and you could possibly pull the module, the bad apple, if you will. Have you seen that happen with that level of data you're providing?
All the time. Yeah. We have a customer success team of, I think, 8 or 9 people right now. And all they do is go on customer meetings, pull up data from their sites and say, oh, it's very clear that you have a underperforming cell here. We have cross-checked that against your warranty conditions. We believe that it's 100% chance to get a refund on that. So we prepared a report that you can forward to your supplier. Please sign here. And if they refuse it, bring them on a call. That's like our day-to-day business. And in some cases, it might be, oh, there's a cell that's underperforming, but it's by the specification you got, it's not a warranty case. So here's what you can do to mitigate the situation. You need to unplug the rack and balance it manually, and then it'll be fine for another 2 weeks. But here's the bad news. In 2 weeks, you're going to have to do it again. However, if you do it, you can retain 98% of what you thought you would get. If you don't act, it will degrade down to X.
Yeah, and that's why we have these premature augmentations. I want to move off of stationary battery storage. What I thought was interesting was you say you use this application for mobile batteries like EVs and fleet vehicles. I'm curious how that works. Is the battery information being sent to your cloud while the car is on the road, or more when it's back and charging? When do you analyze?
There's basically 2 options that we see among our customers. One is you have a constant data flow through a 5G card. That's mostly in the like premium vehicles and also with commercial vehicles. And then you also have the option that the data is logged in the car and then only sent to the cloud anytime it has a Wi-Fi connection. So maybe when it's at home parking in the garage, or we have electric ships and they might send the data when they are at a harbor, and then they just cross a river for 30, 40 minutes, no data transfer during that. They arrive at the harbor, they send the data.
One of the things I also want to talk about was an issue, especially with lithium batteries, is thermal runaway. It's always been my understanding that a lot of that stems from bad cells. They become problematic and you're not monitoring them. So this is also able to monitor that. Is there any kind of data that you get that signals that, hey, this could lead to a potential issue with some of these batteries? How do y'all find that and what do y'all do?
Yeah, absolutely. And maybe starting at the end, we're super happy to have partnerships with insurance groups now that diligenced us for over 2 years. And that came to the conclusion that by using ACCURE Safety Manager monitoring, the risk profile of these batteries gets so much better that they can get better insurance conditions, meaning lower premiums, lower requirements for spacing, for fire extinguishing and the likes. This is really great because insurances are the experts on risk. And if they can come to the conclusion that they're happier getting less money from a customer because the risk is going down so much, this is quite an endorsement. And we're really proud to do that. And also to really support the industry because insurance rates for batteries have gone up a lot over the last 5 years. And this is really a burden to any owner and operator. And if we can help to get them back into a range that they're used to from solar and wind and make it easier to invest in this asset class, that's really cool. So how do we do it? You mentioned in the beginning absolutely correctly that most of the thermal runaways that we see in batteries, or a big part, is caused by manufacturing faults. And if you think about battery production, it's such a complex process that includes pasting a slurry on an aluminum foil that runs at 100 meters per second, and then drying it, and then combining it with something else and welding it. And it's such a complex and nuanced process that by nature, the output of battery production lines has a natural spread. So when you take 10 batteries that were just produced right after each other, they will all be slightly different from each other. The industry has basically gotten used to that by just testing and sorting them. At the end of a production line, you always have tests, and then you put the good ones into one bucket, the B-class ones into one bucket, and then the ones that go to Alibaba, right? And that's the reason why you can actually buy real high or tier 1 batteries on Alibaba, but they are the scrap bucket. They have the original logo and they were produced on this line, but they didn't make the test. So you really shouldn't buy top brand batteries on any auction platform because they are genuine, but they're genuinely garbage. So
it's good to know.
But still, you know, if a battery facility produces 100,000 or 1 million batteries per day and you have a failure rate of 1 in a million, which is low, you're still producing one dangerous battery per day, right? And so because it only takes one battery in the site to cause a catastrophe, the numbers stack up. Batteries are generally a safe technology, but we have seen, unfortunately, thermal runaway stories, and there's actually something you can do. There are some incidents where you have water ingress. Okay, no monitoring in this world will help you here. If someone drops a monkey wrench on a cell and shorts it, no monitoring will help you. But all these manufacturing defects, or most of them, we can actually see that an irregular behavior is building up over time. Maybe the battery is starting to generate gas. Maybe the battery is starting to plate. Plating means when the lithium ions, which should be ions, become lithium metal. And lithium metal is a highly reactive material that you don't want in a cell. And the BMS has no chance. The BMS would never see these things because the BMS has a switch. And if it sees something and opens the switch, there's no way to close it again. The way you calibrate it is robustly, right? If the BMS would open the switch at the slightest change in behavior, you would end up with a site that's 50% down all the time. So the BMS has to be really robust against small changes. But in the cloud, we can be as differentiated as we want, and then we can track it over time, and we can compare it to other batteries, and then we can say, hey, this is very early but we're 95% sure that this battery will sooner or later blow up. You're owner and operator. Ultimately, it's your decision, but we highly recommend to take action now.
Yeah, I'm sure they would probably consider that. Yeah. So
the first time is always, we got to send someone. And what does 95% sure mean? And then we really try to convince them by, sometimes we share the costs on tests. We say, hey, you get it out and we will pay 50% of the mechanical testing of this module. And then if they find a clear failure, it just builds, trust. And with that trust, the second and third incident that we flag is much easier because they know, hey, the first one was a slam dunk in terms of accuracy. And so from that, we can take it.
We've basically spent the entire interview talking about lithium batteries, but you say you manage over 100 battery types. Is that just lithium or are we getting into other chemistries now?
So I would love to monitor some iron flow batteries. Wink, wink. At ACCURE, 100% of our commercial projects right now are lithium ion. And so the over 100 battery types that we have really are the entire spectrum of lithium ion from NMC, NCA, LFP, LTO. These are all the different chemistries, combinations of cathodes and anodes, and all the different form factors, pouch cells, prismatic cells, cylindrical cells. In the stationary space, they're just getting bigger and bigger. So some of the older sites that we have had like 40 amp hour cells. Now we're looking at 280, turning into 300 now. And we've seen the first 500 amp hour cells. They're 70 kilos and beyond and really difficult to move around, actually. We cover the entire spectrum of lithium ion, but there's going to be some interesting new R&D type projects coming this year. Sodium ion. We've got one customer that uses them now. And in my last role at the uni, I covered a lot of long-term storage. So zinc-based batteries, iron-based batteries. How do you see the industry? What's your take on that?
I think you're definitely going to see more and more different kinds of chemistries on there, is my personal opinion. I think that lithium definitely needs precedence with EVs. So as far as you go into stationary storage, probably need to be looking at other things as well. That leads us to the next question of what is next for you guys. A lot of best projects out there, a lot of monitoring going on, a lot of monitoring that they've never had before on the facilities that are already out there. So how do you drink from that fire hose? What are you focusing on over the next year or so?
Yeah, for us as a relatively young company, we've been around for about 4 years now. It's really important to keep focus. And we aspire to be the best at what we do. And that's only possible if you limit yourself quite a bit to not doing everything. And it's so difficult because in the battery industry, there's so many opportunities and there's so many things you could do. But I think from a societal perspective, it doesn't make sense if everyone's doing everything. But I'd rather have people limiting themselves to what they're really good at and then providing value to each other. So our plan for this year and for next is really to scale up together with our existing customers. It's so great if you have happy customers. That makes my job as CEO fun most days. And so scaling with existing customers, they're all growing like crazy. 30%, 50% year over year growth. Sometimes you have a step function of, hey, we're adding another gigawatt hour. And so really focusing on the existing customers and making sure that they're well served, adding similar customers where we can leverage our experience. And we have a few strategic automotive projects. It takes about 6 to 7 years from first project until you go into a series with a major automotive OEM. We're 3 years into this journey, and we have a separate team actually serving these more strategic customers, but we're making good progress there. And the scales, of course, are super interesting in mobility. When you look at 1 million vehicles, that's a lot of kilowatt hours. But really from a product perspective, from a go-to-market perspective, we found that the fit with best owners and operators is so good. And there's so many new players entering the field that this is really our happy place right now. And this is where we want to become a relevant supplier for the industry.
Yeah, very exciting. All right, KP, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Russia.
Crude oil.
Oh, get away from that.
Nuclear.
Difficult, but opportunities.
Coal, and I'll add coal with carbon capture.
I think we can do better.
Wind.
As much as possible.
Solar.
It's already everywhere.
Biofuels.
Only for commercial vehicles.
Hydroelectric.
It's great, but I don't think we can extend it a lot in the Western world.
Geothermal.
Absolutely, if we can make it work.
Energy storage, you guys.
Art. Yeah, think about.
Yeah. Energy efficiency.
That's a no-brainer. That should be the first thing we always think about.
And then finally, fusion power.
Ask me in 50 years.
All right. KP Carey's ACCURE Battery Intelligence. Thank you so much for your time.
Jay, thank you for having me.
That was KP Carey's co-founder and CEO of ACCURE Battery Intelligence, a cloud service for battery management systems based in Germany. I want to thank KP for his time, as well as Matt Besh at ACCURE and Cassandra Sweet at Cool Green Media for setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at HostEnergy and Twitter at HostEnergyCast. All guests are sent the wrong completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 179. Be sure to join us next week when we meet 3 of the top energy storage market designers here in the U.S. as part of my ISO panel from PowerGen earlier this year. Until then, I'm Jay Downhauer. We'll see you next time.